In this video, we're going to take a look at the SAT practice test number 1, and we're going to do module 2 of the math portion of that test. This is produced by the College Board. It is one of the paper practice tests that you can find on the SAT suite on the College Board website. As an added note to this video, I want to mention that on the current SAT suite of the College Board website, Test 1 is no longer available. It is available through a link, and I'll make a link in the description of this video to do that, for you to be able to access that. So you should be able to get practice test 1 as a PDF. And again, we're going to take a look at module 2 of practice test 1 and of the math portion. Obviously, it starts here on page 40. You can read the notes if you'd like and look at these formulas for reference. I may reference these as we're doing some problems. So module 2 starts here, and let's go through the questions. The first question says, Tilly earns P dollars for every W hours of work. Which expression represents the amount of money in dollars Tilly earns for 39 W hours of work? That 39 is W is not 39 times W. It's 39 hours of work. So 39 is the W. If she earns 39 hours at P dollars an hour, then 39 times P, that is A, so 39P is the answer, 39 times P. So A is the correct answer there. For problem number 2, it says Juan rides his bike at an average rate of 5.7 minutes per mile. Which function M models the number of minutes it takes Juan to ride X miles? Now, you can do this in your head. You can also think of this as a fraction. When we say 5.7 minutes per mile, think of doing the labels. So 5.7 minutes per mile is like 5.7 minutes divided by 1 mile. If we're trying to figure out how many minutes it takes to ride X miles, note that if we multiply times X miles, what will happen is the miles on the bottom and the mile label here in the numerator will cancel each other out. And what we're getting there is just 5.7 times X. And that's giving us the amount of minutes that we're trying to get. So that is letter D. 5.7 times X is the amount of minutes it takes to ride X miles. For question number 3, the solution to the given system of equations is xy. What is the value of y? Now, in this system of equations, we have 3x is equal to 12 and negative 3x plus y is equal to negative 6. What I would do is I would use the elimination method. You could also use the substitution method, but I would use the elimination method and simply add the two equations together. Again, that's what you do in the elimination. Method for solving a system of equations. And if you added those two equations together, you add the left-hand sides, 3x plus negative 3x plus y would just give you y on the left-hand side. And then you'd add the right-hand sides. 12 plus negative 6 would be a positive 6. So you would get a y value of 6. Now, if you wanted to find the entire solution, then you'd go plug that 6 into the second equation and solve for x. This problem doesn't ask for the entire solution. It just asks what's the value of y. And we already know that it's 6. And therefore, we're looking at B as our answer. For problem number 4, it says the equation gives the speed in miles per hour of a certain car t seconds after it began to accelerate. What is the speed in miles per hour of the car 5 seconds after it began to accelerate? So if t seconds after it begins to accelerate, we are going to plug in 5 for t. When I do that, I get s is equal to 40 plus 3 times 5, which is 55. So that means 5 seconds after it begins to accelerate, the car should be at 55 miles per hour. So the answer there is D. So D. For problem number 5, let's zoom that one out a little bit so we can read it. It says, for the right triangle shown, A is 4, B is 5, write an expression that represents the value of C. Now, in this case, C is the hypotenuse of a right triangle. A and B are the legs of a right triangle. And one of the formulas that was our reference formulas for the test is the Pythagorean theorem, which says C squared is equal to A squared plus B squared. And so if we're trying to find C, we could find C squared first. Since A is 4, we'd get 4 squared, and B is 5, we'd get 5 squared. Now, C is a length. Because C is a length, we can find it by taking a positive square root of both sides. If this were not a if this were not a length, we'd have to do the positive and the negative square root of both sides. But we get square root of 4 squared plus 5 squared, which is D. So here we can say that our answer is D. And just look back at the exam, what it had. I'm using this reference here, that C squared is equal to A squared plus B squared on a right triangle. Let's take a look at problem number 6. So it says, what is the solution to the given equation? That means I have to solve this equation for x. We have 4x plus 5 is equal to 165. What I would do is I'd begin by subtracting 5 from both sides. So 4x is equal to 160. And then I would divide both sides by 4. When I divide the right-hand side by 4, I end up with 40. So the solution is x equals 40. And that's the answer to problem 6. Let's take a look at problem 7. This says the x-intercept of the graph shown is x comma 0. What is the value of x? So we're trying to visually locate the x-intercept. The x-intercept is where our graph hits the x-axis. And it's pretty clear that that is this point. If you know that this is the graph of a parabola, or it looks like the graph of a parabola, and so it's at this point, it looks like that value is at 7. So we'd say it looks like the value of x on the x-intercept is x equals 7 in this case. Let's take a look at problem number 8. It says a function is defined by f of x is equal to 1 over 10 times x minus 2. What is the y-intercept of the graph y equals f of x in the xy plane? Now, if you know about lines, what we have here is essentially the line y equals 1 over 10 times x minus 2. The y-intercept is where x is equal to 0. If you plug in a 0 for x, you get y equals 1 over 10 times 0 minus 2, which gives you a negative 2. And so therefore the y-intercept is the point 0, negative 2, which is B. So option B would be the solution. You can also recognize that this is the slope-intercept form of the line, and the y-intercept is 0, negative 2. You can do it that way as well. Problem number 9 says the function f is defined by f of x is equal to 7x raised to the third power. In the xy plane, the graph of y equals g of x is the result of shifting the graph y equals f of x down 2 units. What equation defines the function g? So this is knowing that a shift down is an subtraction of a number from our result. So what we're going to do, a shift down of 2 units, is taking my expression, which is 7x raised to the third power, and subtracting 2 units off of the end of that. So 7x raised to the third power minus 2 would be a shift down of 2 units from my function f of x. So that is option D, and D is the correct answer. Let's take a look at problem number 10. I will redo this just a bit in terms of spacing. This says which ordered pair is a solution to the given system of equations. Now, there's multiple ways you could do this. The way I like to do this is to realize, so you could just plug in various points. That's one way, and to check both equations. If both equations are true, then we're good to go. Another way you can do this is manually by noticing that the first equation doesn't even have a y in it. That means when you take x plus 7 is equal to 10, you could subtract 7 from both sides and get x equals 3. That's the first equation. And then in the second equation, you could plug in that 3. 3 plus 7 quantity squared. Oops. And that's going to give you your y. 3 plus 7 is 10. 10 squared is 100. So now I know that there's actually only one point that works, and that's the point 3, 100. And therefore, A is the correct answer for problem number 10. Let's take a look at problem number 11. Which expression is equivalent to 7x raised to the third power plus 7x minus the quantity 6x raised to the third power minus 3x? The key thing here is that you need to distribute that minus sign. I'll write the steps on this. You don't have to. You can just do this in your head if you want. But we're going to be subtracting 6x raised to the third power. And then when I subtract a minus 3x, that's like adding 3x. So what I end up with when I combine like terms is a 1x raised to the third power, or I can just say x raised to the third power. We don't have to write the coefficient of 1, plus 10x. And that's A. That's option A. And so the answer to number 11 is option A. Let's take a look at problem number 12. The function p is defined by p of n is equal to 7n raised to the third power. What is the value of n when p of n is equal to 56? It's basically asking me what's happening when the output is 56. We know that the output is 7n raised to the third, and now we know that that's supposed to be equal to 56 in this case. So all we have to do is solve this equation if we want to figure out what the correct value of n is. I would divide both sides by 7. We'd end up with n raised to the third power is equal to 8. And then you can take a cube root of both sides, and the 1/3 power, a 1/3 power on both sides. So the cube root, or 1/3 power, on both sides would give us n is equal to 2. And so obviously, once again, that's answer A. We got a couple of 3 A's in a row in these last 3 problems. Let's check out problem number 13. It says, in the figure shown, line C intersects parallel lines S and T. What is the value of X? Now, because S and T are parallel, what's going to happen is that this angle here is also going to be 110 degrees. It's going to be the exact same as this one. So these two angles are going to be the same. And then it's worth noting that this 110 and your angle X are angles on a straight line. Because two angles because if I have angles like this, which together form a straight line, that means 110 plus x has to be equal to 180. And that means x is going to be 70 degrees. Let's see if I have the degree mark on here. So there that is. X is equal to 70 degrees. Let's take a look at problem 14. Oh, I got my clear that drawing. It says a list of 10 data values is shown. What is the mean of these data? So we need to understand what the average or the mean is. That's where we add up all the numbers and then divide by the numbers in the number of values in our data set. So we'd add up all of these values, 6 plus 8 plus 16 plus 4 plus 17 plus 26 plus 8 plus 5 plus 5 plus 5. And then we notice that 6, 8, 16, 4, 17, 26, 8, 5, 5, 5. Add all those up. Because there are 10 data values, we end up dividing by 10. And when you do that, you end up getting an average or a mean, which is equal to 10. You can do that on your own if you'd like and confirm that we've gotten the right number. Let's go ahead and do problem 15. The equation E of t equals 5 times 1.8 raised to the tth power gives the estimated number of employees at a restaurant where t is the number of years since the restaurant opened. Which of the following is the best interpretation of the number 5 in this context? Well, think about what 5 is. 5 is the coefficient here. And if you plug in a value of 0, so plug in a value of 0, you end up getting 5 times 1.8 raised to the 0th power, which is 5. That means at time 0, this restaurant had 5 employees according to the equation. So the best interpretation of that 5 is that it's the number of employees when the restaurant opened. At time 0, when the restaurant opened, we had 5 employees. So the correct answer is A. Let's do problem number 16. What is the minimum value of the given function? Now, there's a couple of ways you can interpret this or you can understand this problem. If you want, you can see that this is a quadratic equation, so you can find the vertex of this quadratic equation. The vertex is going to be the minimum value. The other way you could interpret this is you can see that since x squared is always going to be non-negative, the smallest value of x squared is going to happen when you plug in a 0. So if you plug in an x of 0, and by the way, that's what you would have found if you said, well, the vertex is the opposite of b over 2a as an x value, or has an x value of opposite of b over 2a. and the b value here is 0. So you would have gotten negative 0 over 2 times 1, which is 0. So we get an x value of 0, but that's not the minimum value of the function. That is the x value that gives you the minimum value. And again, you could have solved that either by doing the vertex calculation like I did, or notice that x squared is always non-negative, so the lowest value is going to be 0. Once we find that the lowest output value happens when x is equal to 0, plug in 0 into the function, and that gives you 0 squared plus 55, which is 55. So the minimum output value of the function is 55, and that happens when the x value is 0. So the answer there is B. The minimum value is 55. Problem number 17 says each year the value of an investment increases by 0.49% of its value by the previous year, of the value the previous years. Which of the following functions best models how the value of the investment changes over time? So it's increasing by a percentage of its value the previous year. This means it's going to be a repeated multiplication, and repeated multiplication with an increase. So it's going to be an increasing exponential. So that is option C. Increasing exponential. Increasing, and it's a percentage of the value of the previous year. So increasing exponential, that's C. Let's take a look at problem 18. The population of Greenville increased by 7% from 2015 to 2016. If the population is K times, if the 2016 population is K times the 2015 population, what is the value of K? So it's an increased by 7%. That's the whole key here. So if we're increased by 7%, think of 7% as 0.07, but it's increased from what it used to be. So we're going to have to add on 100%. So we're going to have to multiply times 1.07. So it's increased by 7% from a base of 100%. So the total multiplication is basically 107%, which is 1.07 as a decimal. And therefore, C is the correct answer there. So the answer to 18 is C. '19 says, which expression is equivalent to A raised to the 11/12 power, where A is a positive number? Now, if I were to rewrite that immediately, A to the 11/12 power is going to be some sort of 12th root of A raised to the 11th power. I can see what these are. So if we're talking about 12th roots, it'd be A to the 11th power. Whoops. And that means obviously option A doesn't work because that's the 12th root of A to the 132. So we're going to have to write this different than the 12th root. And so what we need to do is write that fraction 11 over 12 as something else. And so 11 over 12, one way I can rewrite that is multiply times 12 over 12, multiply times 1. So we're going to take a raised to the fraction, and we're going to take 11 times 12 over 12 times 12. That will give me a raised to the 132 power divided by 144. So the power is 132 over 144. And now I can see that this is equivalent to the 144th root of a raised to the 132nd power. And that's option B there. So option B is the correct answer. Problem number 20 says an event planner is planning a party. It costs the event planner a one-time fee of $35 to rent a venue and $10.25 per attendee. The event planner has a budget of $200. What's the greatest number of attendees possible without exceeding the budget? Now, the way I do this is I start out by dealing with the cost. The cost is going to be 35 plus $10.25 per guest or per person. So that's how much it's going to cost. And the planner only has a budget of $200. So we have to be at or under $200. I could put a less than or equal to sign here to be a little bit more proper, but I'll just use the equal sign. I think it's pretty straightforward. Then we'd subtract 35 from each side. We get $10.25 times the number of people is equal to 165. And then I divide both sides by $10.20. And if we were precise, the number of people would be 16.09756. Obviously, we can't invite 0.9756 of a person. That doesn't work. By the way, that's just a rounded number. And so what we could do in maximum, we could at maximum invite 16 guests. If we tried to invite 17, we'd be over that $200 allowance. And by the way, you could check this if you want to by plugging in 16 and seeing that 35 plus $10.25 times 16 is $199. So we're just under our $200 budget. But if we would have invited 17 guests, we would have been over our $200 budget. Number 21 says if the absolute value of 4x minus 4 is equal to 112, what is the positive value of x minus 1? Now, the key to this is to realize that if we have absolute value of 4x minus 4 is equal to 112, I can factor out a 4 on the left-hand side. We get 4 times x minus 1 is equal to 112. And then I can divide both sides by 4. When we take 112 and divide it by 4, we get 28. And so what you'd get is the absolute value of x minus 1 is equal to 28. Now, if we were to actually solve this, we'd say either the x minus 1 could be positive 28, or the x minus 1 could have been a negative 28. This is asking me just for the positive value of x minus 1. So the positive value is 28. That is the positive value of x minus 1. Excuse me. So the positive value of x minus 1 is 28. The negative value would have been x minus 1 is negative 28. Let's take a look at problem 22. A cube has an edge length of 68 inches. A solid sphere with radius of 34 inches is inside the cube such that the sphere touches the center of each face of the cube. To the nearest cubic inch, what is the volume of the space in the cube not taken up by the sphere? Now we're going to have to use some volume formulas. These are actually given on the test. Let me show you those. Volume of a cube is this volume here. It's the volume of length times width times height. If we have a cube, the length, the width, and the height are all the exact same. Volume of a sphere is 4/3 times pi r to the third power. And we have the sphere completely enclosed inside of the cube. So we have a sphere completely enclosed in the sides, or excuse me, inside of a cube, and we're finding the difference essentially between the cube and the sphere, the volume of the cube and the volume of the sphere. And just to visualize this, basically we have a box, this cube, and inside of the cube is existing sphere. And so inside of this box, and we're trying to find the difference in the volume of the box and the sphere. So hopefully that makes sense visually. But the sphere is enclosed inside the box. And if we can look at it, it looks something like that. There. So let's take it. The volume of the cube is going to be length times width times height. Those things are all going to be 68. So edge lengths are all 68. So that's going to be 68 times 68 times 68, or 68 raised to the third power. Now, if you want to do the calculations right now, you can. That's 314,432, 314,432. And then the volume of the sphere is 4/3 times pi times the radius cubed. In this case, the radius, it says, is 34 inches. So we take 4/3 times pi multiplied times 34 raised to the third power, and we'll get some approximate value. Again, the top one is the volume of the sphere, excuse me, the cube, and the bottom is the volume of the sphere. So the volume of the space not taken up by the sphere is, so inside the box not taken up by the sphere, is the difference between those. So we take the 314 1,432, and I would subtract that 4/3 times pi times 34 raised to the third power. When you do that, you get an approximate value of 149,796. And that would be in cubic inches. Again, that's the rounded version. You get a long thing. And so what that is option A. So option A is the answer to 22. Let's take a look at problem 23. It says, what is the diameter of the circle in the xy plane whose equation is x minus 5 squared plus y minus 3 squared is equal to 16? Well, this is the equation of a circle, and the 16 is the radius squared. So radius squared is equal to 16. That means that the radius of this circle is equal to 4. It's asking me for the diameter. The diameter is twice the radius. So the diameter is 2 times 4, or 8. And so B is the answer to number 23. The diameter is 8. Number 24 says, for the exponential function f, the value of f of 1 is k, where k is a constant number. Which of the following equivalent forms of the function f show the value of k as the coefficient or the base? This one's a little bit confusing linguistically, but it's just asking us to say, well, if I know that f of 1 is equal to k, where k is some constant number, what would how could I do that? How could I figure this out? So it's asking for a constant as either the coefficient or the base. Realize that when you want this k to be the base is always going to be changing. So k is not going to be the base. K is going to be some coefficient. And so of these, when I plug in 1, when do I get the coefficient? And the answer is option number C. Because notice that when you plug in 1, you get 1 minus 1 as a exponent, which just gives you the coefficient, right? Because 1.6 raised to the 0th power is going to be 128. That's what you end up with when you plug in 1 into the function. You end up getting 128. All of the other ones here, and for B, you'd get 80 times 1.6. That's not just the coefficient or the base. That's a product. Here you'd get 204.8 divided by 1.6. That's not just the coefficient. And here you get 50 times 1.6 squared, which is not just the coefficient. So in this case, we're looking at option C as our final answer. When you plug in 1, you get a constant, and that constant is the coefficient of 128. Let's do problem number 25. It says a model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. So we have exponential growth. The model estimates that at the end of 2016, there were 180 squirrels in the population. Which of the following represents this model, where N is the number of squirrels in the population T years after the end of 2015, and T is less than or equal to 5. So basically what this is saying is that 2015 means that T is equal to 0. So T is equal to 0 at 2015. We want that to be 180. And we also want their population to be 150% more than the number of squirrels in the previous year. Remember, more means we're going to start at 100% and then add on 150% more is plus 150%. So we're getting a growth rate of 250%. And that means our base is going to be 2.5. Base is going to be equal to 2.5. And then I want 180 at the end of 2016. That's a T of 1. So we're going to get that when you plug in 1, you should get 180. Notice that that's going to happen with B. We're going to have a base of 2.5. And when you take 72 times 2.5 raised to the first power, you end up getting 180. So that's what we want, and therefore we want the number of squirrels to be equal to 72 times 2.5 raised to the 10th power. And again, that's option B. Problem number 26 says, in a given pair of equations, A and B are constants. The graph of this pair of equations in the xy plane is a pair of perpendicular lines. Which of the following pairs of equations also represents a pair of perpendicular lines? And they're using A's and B's here. So what we can do is we can say that because these two are perpendicular lines, A and B are going to be, if I write, let me state this. Perpendicular lines are such that if I have one as slope n over d, the other has slope d over n. So if one has slope n over d, the other has slope d over, the other has slope negative d over n. Sorry, negative reciprocals is what we're looking for with perpendicular lines. So we want negative reciprocals. So that means the change in x, change in y are going to be reversed and negated. So that means as a fraction, my first equation as a fraction slope is going to be negative 5/7. That's because when you solve this first equation for y, you would subtract 5x from both sides and then divide by 7. That means my other equation has to have slope of 7 over 5. And what that does is it forces A and B to be some sort of scaled factor where A is going to be, let's just say, -7, and B is going to be 5, or some multiple of that. So we can get -7 times some value of n, or 5 times some value of n. Now, for our purposes, the scale is not going to matter. So we can assume that A is -7 and B is 5, and then everything works out. Again, the scaling size does not matter. So let's take a look at problem number A. If we plug in A of -7, B of 5, then my two equations become 10x plus 7y equals 1. And the other one becomes -7x minus 2 times b would be 10 equals 1. 10y, excuse me. These two are not perpendicular, or are they? That's what our question is. So this is the A, and we're deciding whether these two are perpendicular or not. Well, slope 1, slope 2. Slope 1 is going to be negative. Slope 2 is going to also be negative. They're not going to be negative reciprocals of each other. Right? Any perpendicular lines have to be negative reciprocals. Not going to work in this case. Let's take a look at B. Actually, let's erase A here. B also has first line of 10x plus 7y equals 1. And second line, if we use the A of -7, B of 5, would be -7x plus 10y equals 1. And notice that these two are the same. We've switched the x and y's, and we've made one a negative. So B, in fact, does represent perpendicular lines. Okay, so B represents perpendicular lines, and that's all we're asked to find. If you want to be sure of this, you could also plug in -7 and 5 in for option C. If you look at that, we get 10x plus 7y equals 1, and then -14x plus 5y equals 1. These are not negative reciprocals of each other. You have to divide by 2 one way and multiply by 2 the other way. So not negative reciprocals. And then you could also check D and see that D doesn't work. But as we saw, B is the one that does work. B gives us this, and the slope of this first line would be -10/7. The slope of this second line would be 7 over 10. And so obviously that means perpendicular. So again, key thing there is perpendicular lines have slopes that are negative reciprocals. Therefore, A and B can be some scaled version of -7 and 5 respectively. And so let's assume they're -7 and 5 and just plug them in and see what slopes, what other pair gives me perpendicular lines. And that is B. So B gives me perpendicular lines. 27 has x squared minus 34x plus c is equal to 0. In a given equation, c is constant. In the given equation, c is constant. The equation has no real solutions if c is greater than n. What is the least possible value of n? Now, no real solutions. There's a number of ways we can do this. We can graph this and just adjust the c until the vertex of that parabola. So we could graph a parabola and then adjust the c until the vertex just touches the x-axis at one point. That's one option. But the option I'm going to use is to think of the quadratic formula as -b plus or minus the square root of b squared minus 4ac all over 2a. And no real solutions means that this value inside the square root turns out to be negative. So basically, we need to figure out when this value inside the square root is positive and when it turns from positive to negative. Let's just figure out where it is 0, and that will be the place where it turns from positive to negative. In our case, the b value of b is -34. So we'd take -34 quantity squared minus 4. A is the coefficient of x squared, that's 1. And then times c, which is our c, and set that equal to 0. And so when you take -34 squared, you end up with 1,156. And if we added 4c to both sides, we'd get that. 1,156 is equal to 4c. Then divide both sides by 4, you get c equals 289. And basically what's happening here is that anytime c is above 289, then this value is going to be negative, and therefore we are not going to get real solutions. Anytime c is 289 or below, this value will be positive, and therefore we would get real solutions. So the least possible value of n is 289. That's where it changes from real solutions to imaginary solutions. So that's the answer to problem 27. It's what is the least possible value of n? The least possible value of n is equal to 289. Anytime n is above that, then we get no real solutions. So that concludes this video, and we've shown how to do every single question in Module 2 of the SAT practice test number 1 in the math section of that test. So math section, Module 2, SAT practice test number 1.